discuss this theorem. So in this theorem, we have this region S, okay, which is subset of R2. See, it is defined in a different way. Here X is bounded by A and B. So that means we have this region is bounded by this A and B, getting? But Y coordinate is bounded by two different curves, phi1 and phi2. So these are continuous functions. Suppose this is, you can call it as phi1, sorry, phi2, getting, and this is phi1. So this is the region we have, getting. So this is the region we have, which is bounded by AB and phi1 and phi2. Okay, and what is given thing, the function f, which is defined on this region S and which is greater than or equal to 0. Then we have to prove, if you calculate double integration of f over this region S, then also it is greater than or equal to 0. This thing we have to prove. Okay, so what will I do? I'm going to consider a rectangle. Let R is equal to AB cross CD such that that region S is subset of R. See, I'm going to define a rectangle such that, say, suppose C is here and suppose D is here, getting? So we will have D here, getting, and C is here. That means using C and D, we have formed a rectangle R. So this is region S and this is rectangle R. Okay, so we have defined in this way. Okay, and I'm defining a new function G. We are defining G from R to R such that, see, definition of G of xy, see, definition of G of xy, it is same as f of xy if xy belongs to S. That means if you take xy from this set S, then G is nothing but f. And if you take xy from R minus S, R minus means rectangle minus this region, that means this outer part, okay, then its definition is 0. Basically, G is extension of f, simply, ready? G is nothing but f on region S, and if you go outside region S, then we will have value 0. So in this way, we have defined this region, this function G. Okay. See, now what will we do? See, there is no much space to write. It is better to take a screenshot of it, then we will go further. See, here G is nothing but f, extension of f. Both of them are same on S, but if you go outside S, it is 0. So therefore, what can we write? A very important thing I am going to write. I can write double integration of f over S is equal to double integration of G over R. That means integration of f over this region S is nothing but integration of G over this region R, because outside S, G is 0. So that's why outside S, its value will be 0. And inside S, G is nothing but f. So that's why we can write it. It's a very important thing we have got. I will call it as equation number 1. So after that, you know well what we do in case of double integration. We consider a partition, we divide a rectangle into sub-rectangles, we consider infimum, supremum, upper sum, lower sum, and many things. The upper integral, lower integral, actual integral. So here also I am going to do the same. First of all, we have this rectangle AB cross CD. So I am going to divide it into sub-rectangles by taking partition. So let P is equal to P1 cross P2 be partition of rectangle R. Okay, so rectangle R. So this thing is not required. Let me remove it. Okay, already here taken its screenshot also. So let us go further. Where see, P1 means what? P1 means partition of AB. And P2 means what? P2 means partition of CD. Okay. Okay. So that means in this way we have taken partition of AB, we have divided this interval into n subintervals, and we have divided this interval CD into m subintervals. So because of this partition will divide this rectangle into m into n sub-rectangles. Get it? And each we will have a small sub-rectangle, we will call it as Rij. So let Rij is equal to xi minus 1 xi cross y j minus 1 yj. Okay, so this is a very small sub-rectangle. You are getting, because of this vertical partition, horizontal partition, the complete rectangle R is divided into m into n sub-rectangle. So this is the representative of it. Okay, after that I am going to consider small mij. Then, okay, let small mij, you know the definition, it is infimum of g of xy, where xy belongs to Rij, and this is true for all I running from 1 to n and all j running from 1 to m. So by taking infimum of g, we have defined small mij. Similarly, by taking supremum of g, we can define capital Mij, but it is not required in this proof, so I will skip it and we will go further. After defining small Mij, we define lower sum. You remember the definition of lower sum we have already seen. Now, we denote LP, F actually we write, but we are defining for function g, so that's why I am calling it as LPG, which is equal to double summation I running from 1 to n, j running from 1 to m, and this is small mij delta xi delta yj. So this is LPG we have. So again there is no more space to write, so make a screenshot of it, then we will go further. After defining lower sum, normally we define upper sum, but it is not required in this proof. Okay, so what will I do? I will skip that part. But the very important thing I am going to write, that is clearly the lower sum LPG is always less than or equal to actual integral of g. This is, I will call it as inequality number 2. This is also very important. You know that actual integral always lies between lower sum and upper sum. Lower sum is less than actual integral and upper sum is greater than actual integral. Okay, but we are interested in just one part only, so that's why I'm writing lower sum is less than or equal to actual integral of g over r. Okay, after that we will come back to the statement. Okay, so in statement they say the function is greater than or equal to 0. I will write given part is f of xy is greater than or equal to 0 for all xy belongs to S. See, this part is not required, so I will remove this one. Okay, let us continue. So implies, you remember the definition of g. G is nothing but f on S, and if you go outside it is nothing but 0. Getting? So if f is greater than or equal to 0, I can write g of xy is also greater than or equal to 0 for all xy belongs to R. Okay, so implies. So function g is non-negative. We define small mij with the help by taking infimum of g. If function is non-negative, small mij is also non-negative. So therefore, small mij is also greater than or equal to 0 for all I running from 1 to n and j running from 1 to m. So therefore, if you take summation, doesn't matter, all of them are greater than or equal to 0. So if you take summation, then also it is greater than or equal to 0. I running from 1 to n, j running from 1 to m. So that is also greater than or equal to 0. This is definition of what? This is definition of LPG, which is greater than or equal to 0. But see, LPG, this integral is greater than or equal to LPG. So therefore, I can write integral g over r, that is also greater than or equal to 0. from 2. Simply, simple logic I am applying. A less than B, B less than C, though A less than C. So see, 0 less than LPG, LPG less than integral, so therefore 0 less than integral. Okay. But see, equation number 1 says integration of f over s is equal to integration of g over r. So that's why I can write this is nothing but integration of f over s, which is also greater than or equal to 0. So in this way, we proved the required thing. Okay. So you can make a screenshot of it. After that, we will stop. Thank you. Bye bye.